All right, we might make a start. Good morning, everybody. My name's Scott Power. I'm the Director of the Centre for Applied Climate Sciences at UniSQ. And in the Centre for Applied Climate Sciences, we conduct research in physical climate science, climate adaptation, and agricultural modelling, amongst other things. And we also conduct extension, monitoring, evaluation, and adoption to help people, governments, and businesses in Australia and overseas manage some of the risks they face from climate variability and climate change. And we have about 20 staff, mostly in Southeast Queensland, but some in Melbourne, like Tim I see online and myself half the time, and also in the UK. We also employ a network of 15 so-called climate mates across Northern Australia who act as champions in the use of meteorological and climate science in decision-making. And we also have very fortunate to have 20 PhD students. And before we proceed, I'd like to, on behalf of the university and the centre, acknowledge the traditional owners of the land on which we gather, and I'd also like to pay our respects to elders past, present, and emerging. And this morning, we're very lucky to have two speakers. The first speaker will be Francis Kasenka, and then we'll have Dukan Anvo. And Dukan has been a multidisciplinary computational modeler across different disciplines, including engineering, both mechanics and materials, climate, agriculture, and economics. And what he tends to do is integrate data with physical and mathematical models to tackle various climate challenges. And he's currently conducting research, in addition to his AgReFed work, currently conducting research to assist decision makers in agriculture and society more broadly. Dukan is one of the principal developments of the AgReFed platform that you're going to hear about today. And his research is supported by, in Australia, GRDC, MLA, and the ARC, and internationally from major international funders like the German IKI, International Climate Initiative. And Dr. Francis Kasenka is UniSQ's Senior Digital Research Advisor, and he's an IT service manager and researcher with international experience as a practitioner and published researcher. And he's undertaken research funded by the ARC, ARDC, and GRDC. And Francis co-authored the AgReFed project grant application, and he's UniSQ's lead for the AgReFed project. And so today, Dukan and Francis are going to tell us all there is to know about the AgReFed platform. Thank you very much. Thanks, Francis. And I'll just remind everyone, if you have questions, we don't have, put them in the Q&A, and then we'll address them at the end. So we'll have some Q&A at the end. The session is down for 1.5 hours, but we suspect it may go much shorter than that. So there'll be plenty of time for discussion and questions at the end. Thank you, Francis.
Thank you, Scott, for that introduction. I'll go straight into the slides and I'll walk through the first bit of the presentation, and Dukan will take us through the second bit of the presentation. So the AgReFed stands for an Agricultural Research Federation. It's an organization that is a federated community of universities, industry, government. UniSQ is a member of the Agricultural Research Federation. And so we have representation at the various levels of AgReFed. At the council level, we have Dr. Sam Rose and Professor Shabazz Mushtaq. I sit at the technical committee level, and Dukan is in the project operation team. The Australian Agricultural Research data continues to be one that is distributed. And so what AgReFed tries to do is respect that and not create what you would call an agricultural cloud, but rather a federated agricultural research data cloud. The big motivation is to have this done in a way that is fair, where fair stands for findable, accessible, interoperable, and reusable. So the idea is to have not only the data sets, but the tools, case studies, workflows, examples, as well as learning materials presented in a platform that can be used by the agricultural community, including university researchers, industry practitioners, as well as governments. So a bit of a background on the AgReFed project. So the funding application started in 2019, and I share this because I'm speaking with researchers who are probably going through similar journeys. So our initial approach to the funding agency, in this instance, research infrastructure provider, the Australian Research Data Commons, was unsuccessful. So in 2019, together with the Federation University, we came up with the concept of developing a platform that could make working with agricultural research data easier. And we presented that proposal, but that year, most of the funding went to the life sciences. So we went back in 2020, using the information that had been given back to us, but also the feedback that we provided, and argued the case for funding, and this time around it was successful. So we received the funding in 2020, late 2020, and the project timeline started in January 2021. The funding structure is the ARDC matched funding. So the ARDC contributed 431,000, and the three partners, so Federation University, the lead, University of Sydney, and University of Southern Queensland, and QSIF matched that funding. The project has many collaborators. So the collaborators are organizations that are members of AgReFed and engaged in agricultural research, and therefore stakeholders keen on contributing assets, including datasets, workflows, tools, and vocabularies that can be used to add to what is being done, as well as test the products that are being developed and shared. So the collaborators include the University of Western Australia, University of Adelaide, the Department of Primary Industries and Regional Development in WA, the Grains Research Development Corporation, and CSIRO. So the project structure, so the time frame, 3 years, so 2021 to June 2023 was the time we've been given to develop the platform and tools. And so the project partner, project outputs include 4 work packages. So all the partners are contributing to the development of the platform. And during this presentation, it'll become clear what that platform is. It's a digital platform accessible from the cloud that can be used to share datasets, workflows, training materials, and exemplars. So Federation University, as a lead, is responsible for developing a fair assessment tool. The University of Sydney is developing a data aggregator or a data harvester tool. And then the University of Southern Queensland is contributing a data set, in this instance, the Drought monitor, and crop modeling and management work packages. So we'll talk about and focus more on UniSQ's contribution to the project and how we've gotten to the outputs and the experience and journey that we've gone through. And then the second part, where Dukan makes a presentation, he'll walk through what how those tools actually work and how everything comes together. So the 2 work packages, the Drought Monitor work package and the crop modeling and management work package. So the work packages include datasets, workflows, and training material. Because the project ends in June, most of the work has been done. So we're at the stage where we can actually communicate and share a lot of these results. So in the Drought Monitor work package, which we'll call work package 1, what is being shared with the agricultural community is a database for Australian drought indices. So the goals included providing a platform to securely distribute large network common data format datasets to external collaborators. Also, providing programmatic access to the datasets from internal and external analysis platforms. So whether it's a researcher by their computer, logging in and getting access to the dataset and doing something with it, or a researcher logging into a common platform, which is external to their computer, and they can go ahead and perform some analytics. So some of the challenges were the data needed to be shared with other project collaborators in other institutions. Initially, when the dataset was generated and created by another project, which is the Northern Australian Climate Program, the thinking had not been necessarily to share the netcdf files, because that project primarily shares the maps, and there wasn't any easy mechanism to access those datasets. So there needed to be some rejigging and consultations and renegotiations, and I'll talk about those a bit later. The datasets are several gigabytes in size and continue to grow, because every month new data is generated and added to that growing netcdf library. One of the big things is protecting the interests of the authors and contributors, meaning the researchers, and making sure that their work is not wasted or misused, as well as the funding bodies. So there were licensing commitments around the data sets that were required to ensure that the work got the citations or gets the citations that it deserves, and also the interests of the funding agencies and rights are protected. So we'll talk about that as well. For the second work package, the UniSQ crop modeling and management, the goals are to have an integrated crop modeling on farm using the agricultural production simulator software, AppSim. But that needed to be licensed use of AppSim to be provided from the platform. Again, licensing conversations were needed. Interoperability to allow for porting of whatever scripts or set of tools that a researcher was using in and across the different internal and external environments. AppSim ran in notebooks, and we'll talk about this, and Dukan will demonstrate how that works on the cloud, and documentation. So those were some of the challenges we had to navigate to get to the project deliverables. So the project deliverables include a data server with management and access capability to deliver monthly update drought monitor datasets for AgReFed and NACP projects. Now, it's really servers in plural, because it's a network of servers that have been put together to be able to make the platform work as it should. Then the other output is licensed combined drought indicator FAIR dataset published on the AgReFed platform. The drought monitor metadata is an output as well. So the approach we're taking is to not only have your traditional outputs, but also the non-traditional ones. So to spread or increase the impact surface of the research. So the data set is described and the metadata and published so that it becomes a citable asset that then increases the impact of the research project teams. Documentation of development and findable, accessible, interoperable, reusable process, so the FAIR process. So the idea with this is to make what we've done as transparent as possible and usable and useful to more people. So the idea is to have others use this as an exemplar to take their research further as well, especially in the agricultural domain. Then user cases, which Dukan will go through, the drought monitor, climate modeling, and management user cases. And there's user training material that's provided just to help any, say, up-and-coming researcher, like your early career researcher or HDR student. So how we deliver the outputs. So the data sets, the workflows, and training materials. To make them findable, we had to assign persistent identifiers. So we worked closely with the UniSQ library. And the persistent identifiers include the digital object identifiers for the data sets. And this help with allowing provenance. So they can be tracked back to any publication can be tracked back to the source data sets and any instrumentation that was used, as well as the authors and contributors. So the authors and contributors would have OC IDs, so the original researcher and contributor identifier. So both for the metadata and the data. The outputs are made accessible to both humans and machines by design. So the idea is agency now is not just by humans. We now have artificial intelligence, which we have to think about when we're generating research outputs, because the generative artificial intelligence will interact with the products as well. So the idea is to have it presented in a way that will have impact through human as well as machine agency. So via servers, virtual machines, and containers. The outputs have been made interoperable by using open source frameworks and technologies, including Jupyter notebooks and GitHub, and Dukan will show how this work, and national collaborative research infrastructure, scheme-funded infrastructure. So this project was actually funded through NCRIS funding that's supplied via the Australian Research Data Commons. And finally, reusable. So I think the beginnings of science is having results that are repeatable or replicable. So presenting our results in a way that allows for others in an appropriate way that protects the IP and ownership through appropriate licensing and obviously attribution to take the work, reuse it, and get results, and perhaps even extend it or improve it. So the technical solution development was iterative. So like most things, we had to try a number of times before we got to Nirvana, you know. The original idea evolved. So initially in iteration, the conceptual iteration, so we call that iteration 0, the plan was to have a thematic real-time environmental distributed data service, data server, a threads data server. We attempted to do this, and we found that it was restrictive in the sense that we needed certain expertise that was lacking in the team. And we reached out to UniSQ's ICT, and we also needed physical servers. And we didn't have the funding and budget for that. And so we were introduced to a pilot program that was run by Microsoft. So Microsoft has an Azure pilot program where they gave us resources and a consultant valued at around $5,000 in Microsoft dollars. So it's through that we came across the idea of using the European Center for Nuclear Research virtual machine file system, which is a hub and spoke system So if you think of it as having what they call strata, so stratum 0 being at the center, and then you can then have replicas of the file. So instead of having the threads data server, the datasets, in this instance, the CDI dataset would be from NACP, would be stored securely, and replicas could be accessed. So it seemed like a really good idea, and we developed it to, I think, almost full maturity. And when the money ran out and proved to be too expensive to try and run it off that platform, we reached out to NCRIS funded facilities, so the Nectar virtual machines, and instead of using the Microsoft Azure platform, we ported that technology of the Sun VM file system and placed it within the Nectar virtual machine environment as solution 2, but introduced a hybrid solution where we said we would have a VM server on premise at UniSQ. Through this process, we were working with the e-research team, and I believe Richard is in this meeting. So Richard has been a key contributor. Richard is UniSQ's HPC systems engineer, and he came up with an even more elegant solution, which is iteration 3, which is we did away with the Sun VM FS and just use the net CDF filing, and which allows for the distribution and the Linux file system as well. So this is a solution that we will be presenting, which has been integrated and will be fully integrated with the AgReFed platform, which also runs on the same Nectar infrastructure and includes firewalls for security and GitHub for like really wide distribution. I'll just step up my speed a little bit. Just looking at the time, I think I'm 5 minutes over, so pardon me. So work package 1 and work package 2 have been deployed, and I'll quickly walk through this architecture. So credit to the NACP team for enabling us to use the dataset to have one of these outputs. So the idea, this is a bit of the NACP workflow. So basically what happens in that project is they use datasets from the Bureau of Meteorology, the Silo Climate Database, and the Normalized Difference Vegetation Index. These are then brought into the UniSQ's HPC environment, and the NACP team, that includes David Corbin, Tobin, and I think there's been a few people who've come and gone, have developed Python scripts that are then used to convert this or integrate those data sets into a CDI that's shared in the form of maps, and you get the netCDF file. So the NACP output data sets are then picked by the Nectar, by the AgReFed project. So Dukan gets those, and that gets put in the research project server. So this becomes the master copy that will then be used in the AgReFed workflow. Now, Richard in the e-research team, so our HPC systems engineer, has developed a container. And what a container does is puts together all the packages, all the software, all the scripts and the workflows and the configurations that are required into a neat portable package that can be run on any infrastructure. So the AppSim is put in that package, and also through a firewall is shared in the Nectar UniSQ tenancy. So all researchers at UniSQ have access to this Nectar platform. So this is infrastructure that's funded that you can use the same way we're using it at no cost to you as a researcher, and we can help you get to that point as well. So what Dukan then does is he uses this as his development environment. So he's not only relying on his desktop, he actually works in a replica of the production environment. So the UniSQ Nectar virtual machine development instances allow Dukan to have the two work packages running. And you can see that the JupyterHub is where he then develops the notebooks and tests them. And the Singularity, which is the container, allows him to have access to a portable AppSim package. Then this is taken through the AgReFed GitHub, which also the other project partners use. So it becomes a common distribution platform. And then through the firewall, because security is a really big thing, access is granted to the final AgReFed platform Nectar tenancy. And then what then happens there is this is a production environment, the AgReFed Nectar Cloud platform that end users will interface with, and that the AgReFed is responsible for securing, for managing users and allowing those interactions. So the notebooks developed by the UniSQ team are then served up from the JupyterHub, and an AppSim server serves up the container for AppSim, and the contribution by University of Sydney, the data harvester, is part of that mix. And then you also have other production containers that are being used or deployed through a firewall and then through GitHub. And users can, as you will see, Dukan will demonstrate, interact with the datasets, the workflows, and the training materials. So just in a nutshell, that's the architecture that's been deployed. So I'll stop talking now and hand over to Dukan. I'll stop my share, so there'll be a bit of a transition. And thank you. We'll take questions at the end of our presentations. Thank you.
Yeah, so thank you very much, Francis. Yeah, let me share my screen. Yeah. Yep, so we thank Francis to present you all of the technical challenge behind the platform that we intend to do, so that we can satisfy some of the design criteria of the platform that we intend to build that should based on agriculture science approach. So we design the platform based on certain design criteria. So firstly, it should be impose low cognitive efforts, so we avoid the need for advanced technical know-how in statistics, agriculture, or climate science. We start with a simple user case or application of the data access, visualization, and mapping. But more advanced user case are also provided for the research level. Secondly, low access barrier. So we try to make all feature of the platform be immediately accessible. So by online clouds, by GitHub open source repository, without requiring individual registration or payment. User currently need to be affiliated to an Australian university with the Australian Access Federation credential, but UniSQ also hosts two local Nectar cloud server with similar Python environment, so that the non-affiliated user can try. Thirdly, low time investment. So the platform should require minimum time commitment by the user. And then actionable output. So the platform output should provide a practical, meaningful input into adaptive decision making in agriculture life. And lastly, universal application. So although we create and test the platform in specific user cases or workflows, our goal was to design a platform that can be used across agriculture sector like crop, livestock, and mixed crop livestock system and sector, and adapt to the regional context nationally and internationally. We also consider other aspects of agriculture research, development, and extension project. For example, agriculture research, development, and extension project often do not consider how to maintain the project long-term legacy, including the dataset and its utility, workflow and frameworks, training material. So for example, at CAT, if we look at NACP phase 3, and the people are going to discuss about the project legacy and how can we going to deliver that. And I heard about some solution by on subscription services. And I think that might impose some access barrier to the user. And AgReFed here might be an option. And if you look at the rich projects, now we're going to final phase, and we're going to, I know that we're going to develop some training documentation and workshop. And probably that is some of the things that we can do with AgReFed approach as well, if, I suggest. And insufficient fund for ongoing personal and technical component of the data storage, maintenance, and management, which can challenge interoperability. And here we provide a solution by on Nectar Cloud Storage and JupyterHub service. So agricultural users, such as researcher, agronomists, farming manager, and farmer need to have tailored and document training in step-by-step satisfy the above criteria. So we do that by using the GitHub wiki here. And finally, we also supply the hardware so that the stakeholder can try and learn whenever and wherever. So the hardware here are the virtual machines, and we build with the building AgReFed Python environment. It's ready, and we just come and try it without any installation need. So just a similar explanation of the platform methods. So if you look at the traditional approach, all of the project and application data set, workflow, like frameworks, training material, were siloed in a local storage, right? And then we, the user need to have their own computer, and they need to install and both tool and package before they can try those development that we have. But in AgReFed approach, we have on the data set and workflow framework, training material were stored in open source and licensed repository on clouds. And we provide a Nectar virtual machine, JupyterHub service, and building AgReFed's Python environment. So here we saw where we can have the ARDC JupyterHub service. So here you see here is where we can access to that platform using the AAF, Australian Access Federation credential. And when we log into it, we have a number of options here, and then we should select the AgReFed Python environment here. So let me try to click on the link. And you sign in, and we select the AgReFed Python environment. We start the server is running, and it's allocate a virtual machine to each user, and it may take several seconds. Yep. So the platform will appear here, and the user can have a the tool here. They can choose the Python environment with all of the buckets already installed in that, and they can try any workflow that provided by the platform. Let me go back to the. Yep. If we, in case we are not affiliated with the an Australian university, UniSQ also provide a local server here. So this is the server for the trial monitor, and we provide a link here. You can also try it to, and in case you want a username and login username and account, we just need to talk to Richard Young. And another server that locally hot in UniSQ is the agriculture modeling server, where we have the AppSim container in tone, and the user can run AppSim and building the production database and doing the analytic by themselves. And here is the link. So in terms of documentation, we use the open source GitHub repository. So here is the AgReFed Agricultural Research Federation GitHub page, and you can see the two popular repository developed by UniSQ here, Drought status and the crop modeling work package. So if we click on the link and we click on any work package, you can get the course for the workflows, like here the how can we work with the trial monitor. Yes, show you the code there. How can we do the quantify the value of trial monitor information? Just some of the application example. And then if we want more detailed documentation, you can click on Wikipedia here. So we build up the detailed documentation for each work package. So if you click on the Drought stated workshop here, we can have step-by-step instruction how to use the platform and how to run through all of the workflows that we have. And then remember that we can import the licensing of the workflow that we develop and also the data set that we use here. Yeah, that's the example of the Drought stated work package. And similarly, we can have that for the crop modeling and management work package. So now you go through 5 user case that we develop and show you some of the result and the work that we can receive there. So firstly, we build a user case to work with the trial monitor data. So we can allow the user to map the data for different time scales. So this is for for the 1 month CDI, and then for the last 12 months CDIs. And we can do the time series analysis here. And for user case 2, this is a research level user case. So we build an application using Bayesian approach to allow to use the ground monitor data and information to better allocate the trial system fund. And then we can quantify the economic value of the information there. So here is the mapping of the correlation between the trial monitor indices with the wheat yields across the trade and wheat belts. And we see that there's strong correlation in for the September drought indices here. And we can see here is the map showing the difference between of the drought assistance fund when we use the drought monitor and when we don't have when we didn't use the drought monitor information. And user case 3, where we building a frameworks where a conceptual framework where we try to identify optimal irrigation schedule for sugarcane production. So we see here we input a random irrigation schedule and run upstream sugar, build sugarcane yield database, conduct economic analysis, and then we can pick up the optimal irrigation. So here is a graph for like a plant graph. You see the Drought margin economic outcome for different irrigation schedule here, and we can pick up the optimal one for the plant graph. And then we also have that's similar for the Ratoon 2 here, where we can clearly see what optimal schedule we can pick up. The 4 application is optimize the wheat sowing day across the wheat belts. So we see this is the about 50 sites across the wheat belt where we're trying to optimize the sowing day using the simulated upstream wheat simulation. And for example, here we can visualize the yield distribution, expected yield distribution for a site, and then we can pick up the optimal sowing day here. And then we can go and build an interactive map across on the site, and if the user they just click on the site, it can show up here the optimal sowing day and the potential yield that they can achieve for that season. And finally is we demonstrate here a workflows to make a decision with using the seasonal climate forecast. So in this case, we here where we don't have forecast, we have to base our decision based on the average, historical average, right? But when we have the climate information, we can classify the expected economic outcome condition on the climate forecast, and we can see that they are a lot different with when we have a wet season, a normal season, or dry season here in terms of the picking up the optimal sowing days. And we can display here the forecast values and the optimal sowing day according to different forecast skill. Now, if you want to have a hand-on training, as I said, we have documents on a step-by-step the 2 workshops. The first one is the Drought status workshop. If you go to the GitHub page, you click on the Drought status workshop here. It gives you all of the step-by-step detail, and we provide a link here as well. And similarly, for the ARDC modeling workshop, you can go and pick up on the workshop here, and then we guide you through the step-by-step. And in the future, we intend to deliver the workshop through different ways, and hope that we can attend to that workshop if you want to. Yeah, that's on my details. So I hand over back to Francis to see what we should do. Yeah, thank you.
Thanks, Dukan. If you keep those sharing, that's fine. I'll talk to the last 2 slides using your sharing. So in just this one, this is more an invitation. We would like to work with each one of you. If you're planning any projects and want to see how you can work with us, just reach out via this contact email. Visit our e-research services webpage. There are lots of resources. If you would want us to come and do a presentation to you as a group and work with you around what is achievable, again, we're happy to do that. We have weekly researcher hours, and I note that Chris Davey is in today's call, and he comes along. He's a HDR researcher, and as a team with the library, we're able to work with researchers to make their research data fair and also just answer any questions you might have and provide support. You can follow us on social media as well. Dukan, I might just get you to move to the last slide, and then I can hand back to Scott. Thank you. So this one here is really just acknowledging the external partners that include Federation University, University of Sydney, the Queensland Cyber Infrastructure Foundation, And the internal partners, what I might do is I'll share my slide so that if I can just share mine.
So I stopped sharing my one, right?
Yep.
All right.
And
Okay.
I just make sure everyone that we needed to acknowledge is in there. So cool. So with our internal project contributors, obviously the Center for Applied Climate Sciences. So I thank the leadership of that center. So Scott, Shabazz, David, the whole team, Dukan for all the great work, Gillian along the way, Laura as well, from the Office of Research, Richard Young, Chris Davey, Sam Rose, and the UniSQ ICT library contracts and legal teams. And thank you all for attending the presentation. So I'll hand back to you, Scott.
Thank you very much, Francis, and thanks also, Dr. Ahn, and thank you both for the very informative presentation, and particularly taken with the exciting case studies that you can make use of the platform. I'll pass back to Will. Will, do we have any questions